Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome to this video in which we will learn how to prove the Pythagorean theorem. Now there are a lot of ways to actually do it, but I will show you the simplest way, which is actually my favorite way to do it, and I hope this will kind of make the idea stick into your mind so you don't just memorize the equation, you just know where it comes from. Now, if you didn't watch the last video that I posted, in which I discussed the Pythagorean theorem, what it is exactly, and why I solved some questions involving it, please go and watch it. And let's begin. So this is how we prove it. As you can see, we have these two squares, each one is inside the other. And what we will do is to actually denote the sides. So I will denote this to be A, for example. Actually, let me change the color because a lot of white is here. So okay, so we got A and then we got B. Now, as you can see, these are different. They are not exactly equal. A, B, and this is A, this is B, this is A, B, A, B. And then the side of the inner square is C. Okay, and what the task is to actually calculate the total area of this square. Now, the total area of this square is actually the area of the inner square plus the area of these kind of triangles that are here, right? So we have these triangles, and to actually calculate the total area, we will have to sum the area of the inner square with the area of the four triangles that are here. Okay, now to actually calculate the area of the inner square, it's quite easy. It's not very hard. We know the side length is C, and the area of the total square is just going to be C squared, right? So just C times C, which is C squared. So the total area is going to be C squared plus the area of these four triangles. Now, how do we calculate them? We know that the area of any triangle is just half the base times the height. This is the formula, and we can use it to calculate the area of the four triangles. So 4 times half the base, which can be considered either A or B. There is no difference, right? Half times A times B. Okay, and these four triangles are actually equal, right? They're equal because they have the same sides. They have the same sides and the same hypotenuse as well. So they all have A, B, and C. That's why they are exactly equal in area. And now all of this expression here, all of this expression is equal to the total area of the square, which is also equal to AB times AB, not AB, but A plus B times A plus B, right? Because this is side length and this is side length as well. So we know the total area of this square is just going to be A plus B all squared. So these two expressions are equal, right? So this is the first step to actually calculate or to actually prove the Pythagorean theorem. The next step is just some simple algebra. What I'm going to do is just going to move this thing a little bit to the right so we have more space to do our amazing algebra. Okay, what do we know about this A plus B all squared? Now, maybe you didn't learn this before, but if we have A plus B all squared, it's equal to A squared plus 2AB plus B squared. Okay, this is how you break it down. So let's break it down. So it's going to be equal to A squared plus 2AB plus B squared. And let's simplify the right part. C squared is going to be just the same as it is. And then simplifying 4 and 4 times 1 over 2AB is just going to be 2AB, right? So 4 times 1 over 2 is just 2AB. And we're almost done. As you can see, there is an amazing thing here. You have 2AB here and you have 2AB here. So what if we subtracted 2AB from both sides? What will happen? This is going to cancel with this. So we will get, in the end, a squared plus b squared is equal to c squared. And this is our final expression here, equation. The Pythagorean theorem is proved using this model. And I really think this is the simplest model that you can use to actually prove the Pythagorean theorem. And that's it. Best of luck. Thank you very much.